All right, we're going to finish up a geometry lesson today. And let me get this there. There we go. So part 3. And let me find my notes real quick. Here it is. And you may have done this before. Do you remember congruent triangles? Do you remember doing that in geometry? That's probably where you did proofs of congruent triangles. I don't know. Does it ring a bell? Nobody's saying anything. Mr. Forney? He taught you math? Oh. I thought you said Mr. Forney. All right, so we're going to talk about congruent triangles. So I happen to have some triangles over here. I actually made these just this morning, just so I could have them. All right, so there's a triangle. It's not congruent yet because there's not 2 of them. There's got to be 2 of them. Let's make this just a little bit larger. There we go. Now watch what I'm going to do. On this program, on like a whiteboard, oops, let me put my mic up. This might sound a little better. There we go. If I just copy and paste, tell me something about both of these triangles. They're exactly the same, aren't they? Okay, exactly the same. So what do you think congruent means? These 2 are congruent triangles because I copied and pasted. So what do you think congruent means? They're what? They're exactly the same. Okay, so if I took one, I'll take this one right here, and watch. Are you watching? If I put it, bam, right on top, it's exactly the same one, isn't it? Would you agree? All right. So, I mean, that's nice to say, but that's not really like geometry language. Okay, we're going to talk some geometry language here. So what I'm going to do is, I'll tell you what, in the book, they put some numbers in here. I'll just do it. I'll just put some numbers in here like they do. It's going to go a different direction, but all right. So let's say now I didn't. Oops! Oh my goodness, what's going on? What am I doing? Probably hit it. Oh my word! There we go. Okay, it's working. All right. So I don't know. I must have hit a button on my pen. There's these little buttons there, and I try not to touch them because I'm not really even sure what they do. But let's pretend that this is 50 degrees. I'm not going to put the degree symbol just because it's kind of too small to fit all that stuff in. If I could read my own writing here, let's see. And this is 100, and this is... Now, by the way, we haven't talked about this, but if this is 50 and this is 100, you should know what this one is. What would that be? 30, because they all add up to what? 180. Yeah, we all knew that. And you probably knew that even before you took geometry. So here's the situation. Now, if I come over here, and if I said that these are congruent triangles, then what's this angle right here going to be? If I told you they're congruent triangles, and I got to tell you that first. You can't just assume it, but I told you that these are congruent triangles. So what is this angle right here going to be? It's going to be 50 because they're exactly the same. What's this angle going to be? 100. And this one, 30. Everybody with me on that? Okay, so you know that that's true. Now, that alone does not make them congruent triangles. Everybody hear me on that? Okay, if I just know that the angles are equal to each other, then they're not necessarily congruent triangles. And I'm going to show you that in a little bit. It's called something else if just the angles are equal to each other and you don't know anything about the sides. But I also can say this, that I'll just put some letters in here. That's what I did in my notes, so I'll just do it here. So I'm going to call this A, B, and C. And let's call this D, E, and F. D, E, F. Right there. So now, if I told you that side A is equal to side D, and I told you that B, what do you think, if they're congruent triangles, what do you think side B is equal to over here? Over here. Side B, E, right. I thought you said D, sorry. All right, and then side C is this long one right here, then it would be equal to F. If you know all that stuff is true, if you know that we call them corresponding angles. Remember I took that triangle and I sat it right on top of this one? Okay, there's angles that match up with each other. Okay, they correspond to each other. That's the word that we use. Then if all the corresponding angles are equal to each other and all the corresponding sides are equal to each other, then we know that we have congruent triangles. Are you with me on that? So if all the angles match up and all the sides match up, then we have congruent triangles. But that's 6 different things that we have to know. It's actually, we don't have to know all 6 things in order to say that they're congruent triangles. Okay, we have another way to, somebody get the door, please. We have another way to figure out if they're congruent triangles or not. So let me grab another set of triangles here. Let's grab this one. Come on in. Give them your $2 for a dress down. You gave it to the office. Are you sure? Okay, so here's another triangle. Again, let me just make it just a little bit bigger. That's not too bad. Okay. And what I'm going to do is I'm going to copy and paste again and put them right here. Let's just put them like this. And what I'm going to do is mark these triangles. You've probably seen this before. We'll go with this light blue. Can you see that blue all right? Like that? Is that bright enough? Okay. All right, so what we can do is this. What if I said that this angle was equal to this angle? Is that enough to say that they're congruent triangles? No, not just one angle. But I also said that this one and this one are equal. Do you remember these little tick marks, I call them? Or these little angle marks? Okay, that means this angle right here is equal to this angle right here. All right, if you wanted to, we could call it triangle ABC. And we'll call this DEF again, for lack of imagination with the letters. All right. So if I said angle A is equal to angle D and angle B is equal to angle E, again, that's not enough to show that these triangles are congruent to each other. Okay, you got to know something else. And if they tell you that side AB is equal to side DE, then these two triangles are congruent to each other. All right, that's all I got to know. So before, up here, I said, if you know that all three corresponding angles are equal and all three corresponding sides are equal, then they're congruent to each other. By the way, do you remember the sign for congruency? The symbol? It's an equal sign with what? Little squiggly is what I meant to say. Little squiggly line over top of it. This little symbol means they're congruent to each other, okay? So if you come over here, this is all you know, but this is enough. If I know that I have two angles and a side that's in between those two angles, they call it the included side, all right? So this side is the included side. What's it included between? These two angles that are equal to these two angles. So if I have two angles and an included side equal on one triangle to another triangle, that's all I need. I don't have to have all three angles and all three sides. That's all I need. I just need two angles and one side that's in between those two angles. If I know that, that's enough to say that these triangles are congruent to each other. Okay? And so I have an angle. I have another angle. And where does that side have to be? It's got to be where? There. In what? In between. Right, in between. Or what's the word that I said? It's got to be the included side. Okay, that's the phrase that they use in geometry. They call this the included side. So that means, I'm going to put an S right there. Do you see that? If you have two angles of one triangle equal to two angles of another triangle, and the included sides are equal, see, this is in between, right? The side is in between those two angles, then these are congruent triangles. And that's the kind of stuff they're going to ask you, okay? Are they congruent triangles, and tell me why, and all that kind of stuff. So I could say this. This is how I would write this. Let's do this down here. So I'm going to write triangle. Oops, that's a terrible triangle. Let's try it again. So triangle ABC is congruent to triangle DEF. And watch another thing. Do you see the A and the D are equal to each other? Well, the A and the D should be in the same spot when I write them congruent to each other. You with me on that? Like this, I could call this ABC, or I could call it CBA, or I could call it ACB. Would you agree? But when I'm saying that this triangle is congruent to this, the corresponding angles, the ones that are equal to each other, okay, have to be in the same spot. So if I call this ABC, the A is first. The angle that's equal to angle A has got to be first. The angle that's equal to angle E has got to be second, right? Because B and E are equal to each other. And that must mean that C and F are equal to each other as well, okay? So we have, you got $2 dress down day, so Trey's got the money for that. And do you have a pass? You need to go to the office and get a pass. Well, you still need to go to the office. You still need to go to the office, get a pass. All right, so this is our first theorem. It's called the angle-side-angle theorem. All right, so angle-side-angle, that's what we call it. We don't really call it the ASA theorem. We call it angle-side-angle. All right, so that's the kind of stuff they might ask. They might say, you know, are these triangles congruent to each other? And if so, tell me why. And you would give me a theorem. There's actually 3 of these theorems for congruency. So let me do a couple more. I'll tell you what, just for the sake of making this easy, I'm just going to keep that same triangle. Maybe I'll change the shape of it a little bit. I don't know, maybe something like that. All right, that kind of looks like the one in the book. So I'm going to copy and paste. Again, if I copy and paste, you know that they're exactly the same. But here's another theorem. Let's say I don't know anything about the sides of the triangle, okay? What if I know, the angles of the triangle? I don't know anything. I don't know that this angle is equal to this one, or this one, and this one, this one, this one, okay? But I do know something about the sides. I do know that this side is equal to this side. I know that this one and this one are equal to each other. And I also know that this one and this one are equal to each other. Thank you. You have $2 for dress down. Give it to Trey. So if that's all I know, if I know that the 3 corresponding sides are equal to each other, guess what I know about these triangles? I know that they are what? Congruent to each other. That's right. I know that they're exactly the same. I don't know anything about the angles. All I know is that these 2 sides are equal, these 2 are equal, and these 2 are equal. They're corresponding sides to each other, so I know that these triangles are congruent. What do you think we call the name of this theorem? There's no angles in it. Very good. Side, side, side. So we just put 3 S's here. That's a weird looking S. It's not any better, but that's okay. So side, side, side. So these triangles are congruent to each other because of side, side, side. So that's our side, side, side theorem. I'll just shorten theorem to that. Okay. I'm not going to put numbers in and letters and all that kind of stuff. It's the same deal as what we did before. Okay. If you wanted to call this ABC, DEF, or you could call it, you know, PRQ or XYZ, whatever you want to call it. Okay, but these 2 sides are equal, these 2 and these 2 are equal. Why? Because of the side, side, side theorem. Let's do one more. We have another congruency theorem. Let's push this up a little bit. And let's make this look a little bit different, and we'll maybe angle it a little bit, something like that. All right, so I'm going to copy and paste that. Put this over here, and let's go to some other color. Let's go to this green color. Thank you so much. All right, so what if I have this? What if I was told that this side was equal to this side? Again, that's not enough to say these are congruent triangles. What if I said that these 2, is that enough to say that they're congruent triangles? No, it's not, okay? I have a program where I'm not going to do it right now, but if I was teaching geometry, I got another program that I could put these 2 sides equal to each other, and I could take the triangle and move it around. These would stay the same. Anyway, I'm just not going to do it right now. But these 2 sides are equal to each other. That's not enough. I cannot say that these triangles are congruent to each other. Okay, what I'm going to do, thank you. I'm going to say that this is equal to this. So these are things that I know, all right? They might not put the little tick marks. They maybe put numbers on here. Okay, they might put like a 5 here and a 5 here and a 7 here and a 7 here. They say this is 30 degrees, this is 30 degrees, all right? So they may give you actual numbers here. I'm just showing you in general that these 2 sides are equal, these 2 sides are equal. Oh, I do. All right, and then this is an included angle, right? Again, this is very important. This angle is included. It's in between the 2 sides that are equal to each other. You got it? Okay. Now, it doesn't mean that these 2 sides are equal. It means this one and this one are equal, and this one and this one are equal. So that's the angle that's in between the 2 congruent sides or equal sides. That's enough right there. Okay, that's enough. We're not going to do the proofs on these. If we were in geometry, we may do some proofs on this, but we're not going to do it in here because it's not really geometry class. But I just want to do some review here. So that's enough. I'm telling you right now, that's enough to say that these triangles are congruent to each other if you know this information. So what do we call this theorem? What did we have before? Angle, side, angle. We had side, 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 and now we have what? Side, angle, side. Thank you. And $2 to Trey for dress down. Okay. So we have side, angle, side. All right. So that's the third theorem. So those are our three theorems. We have angle, side, 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 and side, angle, side. Why do we know those? Because we don't have to show that all three sides are equal and all three angles are equal. In this case, I only have to show two sides are equal and one angle that's equal. In the other case before, all I got to do is show three sides and I don't have to show anything about the angles. In the first one we did, I got to show two angles and one side that are equal to each other. That's all I got to do. All right? And in geometry, it's pretty important to say why they're congruent to each other and all that kind of thing. All right? Does that make any sense? You remember this from geometry? Yeah, this was a big deal in geometry, wasn't it? You had a whole entire chapter on this stuff. All right? So now what we're going to do, we are going to do basically the same thing, but we're not going to talk about being congruent. We are going to talk about triangles being similar. Similar triangles. I'll just do that. So let's put that triangle back here, and I want to show you something. Now, watch what I'm going to do here. Oops, come on, grab it. There we go. I am going to copy and paste it, but I'm going to do something. John, you paying attention? Okay. All right, I am going to do something with this. Now, watch very carefully. On this program, if I hit the Shift key, it will keep it in proportion. You guys remember that word? Okay, it'll keep it in proportion. It'll keep it the same exact shape. You see what it's doing? It's not changing the shape. It's not changing the angles. What did it basically just do? The size, right, exactly. It just changed the size. So this angle right here is the same as this angle right here. Okay, same thing with this one and this one, this one and this one. But what about the sides this time? Can we say that these are congruent triangles now? No, because the sides are definitely smaller on this triangle than they are over here. Agreed? Yeah. So we don't call them congruent triangles. We're actually going to call them similar triangles. Okay, they are similar to each other, which means they basically, you probably won't see this in a geometry book, but basically they have the same shape, but they have a different size. Makes sense, doesn't it? Do these triangles have the same shape? Yeah, absolutely. Okay. Do they have the same size? Not at all. Because remember before I took the other one and I picked it up and I stuck it right on top? That's definitely not going to match up, is it? But what do you think does match up, though? Watch the angles. Watch. See if I stick it right there. Okay. Those two angles are exactly the same, aren't they? All right. What about the other ones? Do you think that's going to be true, too? Yeah. Look, stick it right there. Exactly the same. Those angles are the same. What about this one down on the bottom? Yep, exactly the same. Do you agree? All right, that's a good demonstration, right? It's a lot easier doing it here than like on the whiteboard. So they definitely have the same angles. So what can I say? I can say, let's put this in green. I can say that this angle is equal to this angle. Agreed? All right, just showed it. And I could say that this angle is equal to this angle right here. Now, we talked about this earlier. Remember we did the 100 and the 50, and you guys said the other one has to be 30, right? So what if these two angles are equal to each other? What must be true about the third angles? Because what if this was, I don't know, 30, and what if this was 40? 30 and 40 is 70, so this must be what? 110, right? Same thing here. If this is 30 and 40, this has got to be 110. Would you agree? So if you have two triangles and you have two angles on one triangle equaling two angles of another triangle, what's got to be true about that third angle? They got to be equal to each other. Make sense? Yeah. All right. And that's another theorem. We're not going to talk about that, but that is another theorem in geometry. So that must mean that this angle is equal to this angle. Do I have to know that all three angles are equal to each other? No. If I only know two angles of one triangle equal two angles of another triangle, what can I say about those two triangles? I can't say they're congruent. What can I say? They're similar to each other. That's right. So really, do I even need to know that the third angles are equal? No, because I already know that. Because if I know two angles are equal, I know the third's already got to be equal, right? So that's pretty easy. So what do you think we call this theorem? Side? There's no sides here. But I don't even need to know all three. I only need to know two. So what would I call this? Side, side? Why do you keep saying side? We don't know anything about the sides. In fact, the sides aren't even equal to each other. Just angle, angle. Very good. All right. All we got to know is two angles of one triangle equaling two angles of another triangle. Then we can say these triangles are what? Similar to each other. Okay. These triangles are similar. All right. And that's all I got to know. All I got to know is two angles of one equals two angles of another. That means the triangles are similar. Okay. But what must be true about the sides? They're not equal to each other for sure. Okay, but we do know something about it. Let me see what I put in my notes. Yeah, let's do that. Let's put these numbers. What if I said that this was 15 and this was 5? Okay, then what if I said that was 3? And this probably doesn't, let's see. 9. Okay, we'll just say that. So over here, if this is 5 and this is 15, how much bigger is this longer side than this side right here? It's 3 times, isn't it? Okay. So what do you think the length of this side right here is going to be? 9. It's going to be 9. Is it 9 because this side's 9? No, it's because this side is 3 times bigger than this side, and we've already said that they're similar triangles, okay? So if this is 3 times bigger than this, then this side right here has got to be 3 times bigger than this side. So what's this side going to be? 27, that's right. Because why? This is 3 times bigger than this side. Make sense? All right, so when we talk about similar triangles, we say 2 things must be true in order for them to be similar triangles, okay? One thing is the corresponding angles have to be equal to each other. And was that true? Yeah, because we showed that they were equal to each other. But you also can say this, is the corresponding sides are not congruent to each other, and we use this word I think once or twice already, are in what? Starts with a P. No, they're not parallel. When one is like twice as big as the other or 3 times as big as the other and all the sides are the same. Somebody get the door, please. Yeah, what's the word though? What's the geometry word? You're right, it is on the same scale. That's correct, but I'm looking for this word. PR, thank you. Proportion, very good. Okay, we use this, did I spell it right? Proportion, right. Sound it out sometimes. So the corresponding sides are in proportion. What does that mean? That means if I do, let me scooch this up a little bit. I want to keep those triangles in there. Let's do this in yellow just to, let's see what it looks like. When I say they're in proportion, so let's make a ratio between the sides, all right? So let's go from the big triangle. Let's compare. That's what we're doing, is a comparison. Let's compare the big triangle to the small triangle. So I'm going to compare, and we do that as a fraction. This is a ratio. Ratio is a fraction. So if I compare 15 to 5, all the other sides should be equal to each other in comparison. Does that make sense? So how could I set up the other sides? Let's do the 9. I can compare 9 to what? 3. And I should be able to compare what? 27 to 9. Now, we want to see if all these are equal to each other. What's 15? Let's scooch this up a little. Oops. What's 15 over 5? 3. It's 3 over 1, isn't it? What's 9 over 3? It's 3 over 1. What's 27 over 9? It's 3 over 1. Do they all equal the same thing? They do. So we say that these sides are in proportion. I just showed that the sides are in proportion. So if you compare the corresponding sides, like I did right here, they all have to equal each other. That's what it means to be similar. It's a little more complicated than congruent for sure, okay, but that's what it means to be similar. The sides have to be in proportion, or I should say the corresponding sides have to be in proportion, okay, and the corresponding angles have to be equal to each other, okay? Does that ring a bell at all from geometry? All right, good. I hope so. Means you learned something in geometry. That's good. All right, let's do a quick, do I have time? I got 3 minutes. So let's do this. Now, just due to time, I am not going to try to make it look exactly like the book. And these sides may not make any sense. I don't know, but let's just give it a shot. And these angles probably don't make any sense. But 90, 60, 30. Okay, this is probably not actually 90 or 60 or 30, but it's close enough. And 90, 60, 30. Okay, so they give you this, and they say that this side is x, and this side is 6, and this side is 3 and 5. Okay, let's say that's 5. Oh, that's an ugly 5. 5 and 3. We're ready. We're almost ready here, so don't pack up yet. I hear all the clicking of the notebooks. So what we're going to do here, first of all, are they similar triangles? Yes, they are, because I got at least 2 angles from one equal 2 angles of the other. So they are similar. So what I can do now is I could set up a proportion. The bell may ring, but just sit tight. I can set up a proportion. This is supposed to be 6 right here, okay? So what I can do is I can compare this side to this side, because they're the ones that are corresponding to each other. So I could take x and compare it to what? 6. So that should equal, what are the other 2 sides that I know? 5 and 3, right? So what's going to go on top? 5 is going to go on top, 3 is going to go on the bottom. So now, how do I solve for x? How do I find out what x is equal to when I set up this little algebra problem? Do you remember this? Cross multiply. So I get 3x equals what? How about 30? And then x is what? 10. And that's the kind of stuff that you're going to do. Okay, you got to realize they're similar triangles, first of all. Then you can set up a proportion. You can solve for a missing side. And that's the kind of stuff that they're going to ask you to do. So I told you what the homework was yesterday. Hopefully you got started on it. I'll just write it down again. It's pages 36, 37. This will be due on Monday. 36, 37, and 11 to 43 odds. And guess what we're going to have on Monday? We're going to have a quiz on Monday. And it's going to cover, everybody listening? You don't care what it covers? Section R1 and R2. The geometry is not going to be on the quiz, okay? So it's going to cover section R1 and R2. There's 10 questions. I already got it typed up, ready to go. And we're going to do that on Monday. Look, be here on time on Monday. I don't care if you play football. I don't care if you play volleyball. I don't care if you play soccer. I don't care if you're retired. I don't care. Be here on time, okay? Because then you're going to have to take a quiz somewhere else, and you're going to miss class, and it's just going to be a pain. All right, so be here on time. There's no reason for that. I don't care if you got a game that day. It's ridiculous for everybody to be so late. There's no way I should only have like 7, 8 people to begin this class. All right, be here on time. It's important. I don't care if you're a senior. That gives you no reason to not be on time. Well, leave earlier. Okay, that's enough. There you go. Sorry to yell at you last thing of class, but that's how it goes.